Okay, in this video we're going to discuss something called the closed interval method, and that is what you use in order to find absolute extrema. So if you have the graph of the function, it's pretty easy to find absolute extrema over a specific interval. However, if you don't, then we're going to use this method called the closed interval method. So your steps are to find the values of f at the critical numbers of f. So we're going to look at, in the interval from a to b, where are your critical numbers there? So I'm going to take the derivative and find those critical numbers. Then we want to find the values of f at the endpoints of the interval. So I want to find what the y values are of the endpoints of my intervals. And then once I have all of those y values for what happens at my critical numbers and what happens at the endpoints, then I just simply look for the largest value to get my absolute max and the smallest to get my absolute min. So the first thing I'm going to do is I'm going to find the critical numbers of this function. So we have f prime of x is equal to 3x squared minus 6x. I want to set that equal to 0 to find my critical numbers. And so if I factor out a 3x, I'm going to have x minus 2, and that gives me critical numbers at x equals 0 and at x equals 2. So here are my critical numbers. What I'm going to do at this point in time is I'm going to make an xy table, and the values that I'm concerned about are my critical numbers and my endpoints of my interval. So negative 1/2 is the first x that I'm concerned about, and then in order my critical numbers 0 and 2, and then the other endpoint of my interval 4. And those are the only places, those are the only x values for this function where I can have an absolute max or an absolute min over this interval. Okay, it has to happen at the endpoints or at a critical number. I will say this, watch your critical numbers because it matters that they have to be in the interval. So let's say I got a critical number of 5, which I didn't, but if I did, I would not include it here because it's not in the interval from negative 1/2 to 4. So the interval matters the most, and then it's just any critical number in that interval you want to also include. So at this point in time, I just want to find the y values for all of these x values, to do that, you go back to the original function. That always will tell you y values. We don't plug them into the derivative. We plug them into the original function, and we evaluate. So if you were to evaluate at negative 1/2, plug in negative 1/2 for all these x's, you get 1/8. If you plug in 0, you get 1. If you plug in 2, you get negative 3. And if you plug in 4, you get 17. So after doing that, I just look at my y values, and I look for the smallest one, which is here. So that tells me that this is my absolute minimum. And then we look for the largest y value, and that's my absolute maximum. Now I've gone ahead and graphed this in Desmos just to show you what this looks like. Here's our graph. X cubed minus 3x squared plus 1 only over the interval from negative 1/2 to 4, which is what you see here. I have the endpoints highlighted, negative 1/2, comma 1/8, and 4, comma 17. But we can also highlight those critical numbers, which were at 0, comma 1, and at 2, negative 3. And I have all those points listed there. And so I can clearly see that if it is graphed, the absolute minimum over that interval happens here at 2, negative 3, and the absolute maximum on that interval happens here at 4, comma 17.